Let us solve some trigonometric problems. We'll start with easy ones. The first trigonometric problem is if sine theta is equal to 7 by 25, find the value of cos theta and tan theta. Let us understand this problem. To understand this problem, let us draw a right angle triangle. What you see on your screen is triangle ABC, in which angle B is 90 degree and angle C is theta. Let us again revise what we have learned about sine theta. What is sine theta? Sine theta is opposite side upon hypotenuse, and we have been given sine theta value as 7 by 25. So that means opposite side of theta, which is side AB, is 7 units and hypotenuse is 25 units. We need to find out side BC in order to get cos theta and tan theta value. So this is the problem which we are going to solve. From this explanation, the given data is side AB is 7K, side AC is 25K. Now here you have seen I have applied a factor of K to these sides. I will give you a valid explanation at the end of this solution why I am applying a K factor to these sides. We will apply this K factor to all the sides. So as we are applying to all the sides, it doesn't make any difference. But why we are doing this, you will find out at the end of this solution. We will take help of Pythagoras theorem to solve this problem. Why? Because we have two sides of right angle triangle and we need to find out the third side of right angle triangle, which can be found out by applying Pythagoras theorem. As per Pythagoras theorem, hypotenuse square is equal to side 1 square plus side 2 square. Just applying values, what we know, hypotenuse is 25k square is equal to one value of side 1 we know 7k square plus BC is the other side square. 25 square is 625, so we get 625k square is equal to 7 square is 49k, so 49k square plus BC square. Rearranging the terms, we get 625k square minus 49k square is equal to BC square, which is nothing but 576k square is equal to BC square. Applying square root on both sides, we get BC equal to square root of 576k square. So BC is equal to 24k. Now we have the third side BC as 24. So we can easily find out cos theta and tan theta. Let's do that. What is cos theta? Adjacent side upon hypotenuse. So adjacent side of theta is 24, which is BC. Hypotenuse is 25, which is AC. So cos theta is 24 upon 25. And what is tan theta? Opposite side upon adjacent side. So opposite side of angle theta is AB, which is 7, and adjacent side of angle theta is BC, which is 24. So tan theta is equal to 7 upon 24. This is how we have found out the value of cos theta and tan theta. So as promised, let me give you an explanation why we applied K factor when we were finding out the trigonometric ratios. What you see on your screen is two triangles. One triangle is triangle ABC, another is PQR. Triangle ABC is having dimensions 3 base, 4 meter height, and let's say 5 meter is the hypotenuse. And in case of PQR, 6 is the base, 8 is the height, and 10 is the hypotenuse. Let's find out sine theta value for both these triangles. So as we have learned, sine theta is opposite side upon hypotenuse. So opposite side of angle theta in first case is 4, hypotenuse is 5. Sine theta value is 4 upon 5. In second case, the opposite side dimension is 8, hypotenuse is 10. So sine theta is 8 by 10, but if we simplify it, that means we are dividing it by 2, we get 4 by 5. So we are getting the same answer for two different triangles. So that's why we are applying common factor K, as this is a ratio which can be further simplified, and that's why we apply common factor K. This is going to help you in solving the numericals later to avoid mistake. Let us solve the second problem. If tan theta is equal to 3 by 4, find sec theta and cos theta. Let's start with drawing up a triangle and putting up the dimensions. What you see on your screen is triangle PQR, in which angle R is theta. What is tan theta? Here we have given tan theta value as 3 by 4, and definition, tan theta is opposite side upon adjacent side. By combining these two, we get tan theta is equal to, what is the opposite side? Opposite side is PQ, adjacent side QR. Already we have been given value, PQ is equal to 3, QR becomes 4. And we need to find out PR. Given data is PQ is equal to 3K, QR is equal to 4K. We need to find PR. Let's again apply Pythagoras theorem. As per Pythagoras theorem, PR square, which is hypotenuse square, is equal to PQ square, that is side 1 square, and QR square, that is side 2 square. Putting up the values, what we know from given data, PR square is 3K square plus 4K square. So PR square expanding is 9K square plus 16K square. PR square is adding 25K square. Applying square root to both the sides, we get the value PR is equal to 5K, as 25 is square of 5. Now from this data, it is easy to find out sec theta because we have all the values of right angle triangles. Sec theta is hypotenuse upon adjacent side. What is hypotenuse? 5K. Adjacent side is 4K, is 5 upon 4. Let's find out cos theta. Cos theta is adjacent side upon hypotenuse. What is adjacent side? 4K. Hypotenuse is 5K. So cos theta is 4 upon 5. It is very easy, right? Let's look at the next problem. In this, cot theta is given as 40 upon 9. And we have been asked to find the cosec theta and sin theta. To solve this problem, we will use trigonometric identity, which we have learned. If you want to learn the trigonometries again, watch our videos on trigonometric identities. We will use trigonometric identity 1 plus cot square theta is equal to cosec square theta. Let's replace the values of cot square theta as given in the problem. So it becomes 1 plus 40 upon 9 square is equal to cosec square theta. Simplifying this, 1 plus 1600 upon 81. Why? Because 40 square is 1600, 9 square is 81. 1 plus 1600 upon 81 is equal to cosec square theta. Let's further simplify this. So 81 ones are 81 plus 1600 divided by 81. Here what we have done is we made the base common for addition. So 81 plus 1600 divided by 81 is equal to cosec square theta. So adding 1600 plus 81 gives us 1681 divided by 81 is equal to cosec square theta. Let's take square root on both sides. 1681 is a square of 41 and 81 is a square of 9. You can find out the square root of 1681 by prime factorization method. We will make a separate video for prime factorization method. 1681 square root is 41, 81 square root is 9. Now we have to find a sin theta. Do you remember from our first session, cosec theta and sin theta's inverse? Sin theta is equal to 1 upon cosec theta. So sin theta is equal to 1 upon 41 by 9. Simplifying this, sin theta is 9 upon 41. So our answers are cosec theta is 41 upon 9 and sin theta is 9 upon 41. Let us solve an interesting problem now. If 5 sec theta minus 12 cosec theta is equal to 0, we have to find the values for sec theta, cos theta and sin theta. In this problem, we have not been given values for any of the trigonometric ratios directly. So first, we have to find out value for any one trigonometric ratio. Once we get that value, we can then apply Pythagoras theorem and find out the third side of the triangle. Let's see how. Let us write down the equation which is given in the problem. 5 sec theta minus 12 cosec theta is equal to 0. Let's rearrange the term. We take cosec theta to other side of the equal to sign. 5 sec theta is equal to 12 cosec theta. Minus sign become plus. Let us rearrange further. 5 upon 12 is equal to cosec theta upon sec theta. How did we do this? We brought the 12 on the left hand side of equal to sign and we have taken the sec theta to the right hand side of the equal to sign. So 12 came to denominator, so it became 5 by 12. Sec theta went to denominator when it went to other side, so cosec theta upon sec theta. Now if you remember, cosec theta and sec theta both are inverse of what? That's correct. Cosec theta is 1 upon sin theta and sec theta is 1 upon cos theta. Let's apply. So 5 upon 12 is equal to 1 upon sin theta divided by 1 upon cos theta. Let's rearrange the terms. 5 upon 12 is equal to cos theta upon sin theta. How? How did we achieve this? We just simplified this. 1 upon sin theta into cos theta upon 1. This we have simplified and then we have derived cos theta upon sin theta. So 5 by 12 is equal to cos theta upon sin theta. Now do you remember what is cos theta upon sin theta? Yes, that's correct, cot theta. So we get cot theta is equal to 5 upon 12. If you want to understand it better, you can revisit our first session of trigonometry basics wherein we have explained all the trigonometric ratios. Cot theta is adjacent side upon opposite side. So on your screen is right angle triangle ABC with angle theta. From the data above, cot theta is 5 by 12. 5 is adjacent side of theta and 12 is opposite side of theta. We need to find out AC, which is a hypotenuse. Can you do it as per the previous example by applying Pythagoras theorem? Once you do it, then we can find out cos theta, which is adjacent side upon hypotenuse, sec theta, which is hypotenuse upon adjacent side, and sin theta, which is opposite side upon hypotenuse. Try solving this on your own. Let's look at the next problem, which is tan theta is equal to 1. We need to find the values for sin theta plus cos theta upon sec theta plus cosec theta. To solve this problem, let's first draw a right angle triangle. In triangle ABC, B is 90 degree, C is theta. What is tan theta? Opposite side upon adjacent side. We already know the tan theta value, which is already given, 1. That means opposite side must be 1, adjacent side must be 1. Of course, this is a ratio, so that is why we take k factor always. But okay, for this problem, let's just assume opposite side as 1, adjacent side as 1 unit. What is opposite side? It's AB. And what is adjacent side? It is BC. So we need to now find AC. We can do it by Pythagoras theorem. By applying Pythagoras theorem, AC square, that is hypotenuse square, is equal to AB square plus BC square. Side 1 square plus side 2 square. AC square is equal to 1 square plus 1 square. From this data we have derived. AC square is equal to 1 plus 1. AC square is equal to 2. Applying square root on both sides, AC is equal to square root 2. So now we know hypotenuse, which is square root of 2. So now we have all the three sides of a triangle. AB is equal to 1, BC is equal to 1, AC is equal to square root of 2. Now we can find out sin theta, cos theta, sec theta and cosec theta, which is required to solve the equation. What is sin theta? It is opposite side upon hypotenuse. I am just using the short form O upon H. Opposite side of angle theta is AB, which is 1. Hypotenuse is square root 2. So sin theta is 1 upon square root 2. What is cos theta? Adjacent side upon hypotenuse. Adjacent side of angle theta is BC, which is 1. Hypotenuse is square root 2. So cos theta is 1 upon square root 2. What is cosec theta? It is 1 upon sin theta. That is equal to square root of 2 upon 1. That is equal to square root of 2. We can also find out cosec theta as hypotenuse upon opposite side. We get the same answer, square root of 2. As hypotenuse is square root of 2, opposite side is 1. What is sec theta? 1 upon cos theta. Again, square root of 2 upon 1, that is equal to square root of 2. Applying the definition of sec theta, which is hypotenuse upon adjacent side, we get the same result. Hypotenuse is square root of 2, adjacent side is 1. Let's put all these values into the equation. Sin theta value we have, cos theta value we have, sec theta value we have, cosec theta value we have. Sin theta is 1 upon root 2 plus cos theta is 1 upon root 2 upon sec theta is root 2, cosec theta is root 2. Let's simplify numerator first. Numerator is 1 upon root 2 plus 1 upon root 2. So that means base is common, so we can add both 1 plus 1 directly. 1 plus 1 upon root 2, that means 2 root 2. So numerator is 2 root 2. Let's simplify denominator. Root 2 plus root 2 is equal to, we have taken root 2 common out of this. So root 2 into the bracket 1 plus 1. That means 2 root 2. So numerator is 2 upon root 2, denominator is 2 root 2. Let's put back this value into the equation. 2 upon root 2 divided by 2 root 2, which is nothing but 2 upon root 2 divided by 2 root 2 upon 1. Let's simplify this. 2 upon root 2. When it goes into the numerator, inversely it becomes 1 upon 2 root 2. 2 and 2 gets cancelled out. So we get 1 upon root 2 into root 2. Root 2 into root 2 is 2. So answer is 1 upon 2. Let's look at some of the problems where we have to prove left hand side is equal to right hand side. First is sin square theta upon cos theta plus cos theta is equal to sec theta. Let's try to prove this. Left hand side is sin square theta upon cos theta plus cos theta divided by 1. The second term is cos theta. It is nothing but cos theta upon 1. So for addition, we are cross multiplying the denominators. Sin square theta into 1 plus cos theta into cos theta upon cos theta into 1, making the denominator common. So what we get? Sin square theta plus cos theta into cos theta means cos square theta upon denominator cos theta. Let's focus on numerator. Numerator is sin square theta plus cos square theta. Tell me, what is sin square theta plus cos square theta? That's correct. Sin square theta plus cos square theta is equal to 1. So we can say 1 upon cos theta. But what is 1 upon cos theta? Yes, 1 upon cos theta is nothing but sec theta. So sin square theta plus cos theta is equal to sec theta. Easy? Let's see the next. Cos square theta into bracket 1 plus tan square theta is equal to 1. Taking LHS, cos square theta into bracket 1 plus tan square theta. Let's focus on the term which is into bracket. That is 1 plus tan square theta. What is 1 plus tan square theta? 1 plus tan square theta is equal to sec square theta. So we get cos square theta into bracket sec square theta. But we also know that 1 upon cos theta is equal to sec theta. So we get cos square theta into 1 upon cos square theta, as 1 upon cos theta is equal to sec theta. So cos square theta getting cancelled out. We get 1 into 1. Hence, cos square theta into bracket 1 plus tan square theta is equal to 1. Let's take next example. We have to prove square root of 1 minus sin theta upon 1 plus sin theta is equal to sec theta minus tan theta. Looks complicated? Don't worry. We will make it easy for you. Let's take left hand side, which is square root of 1 minus sin theta upon 1 plus sin theta. To solve this, we need to first simplify this left hand side, which is square root of 1 minus sin theta upon 1 plus sin theta. To eliminate the square root, we need to rationalize this. To do this, let's multiply both the numerator and denominator by conjugate of denominator. What is denominator? 1 plus sine theta. So, conjugate of denominator is 1 minus sine theta. Let's multiply both numerator and denominator by square root of 1 minus sine theta. Now, let's simplify denominator first. What is denominator? Square root of 1 plus sine theta into square root of 1 minus sine theta. We can apply a square minus b square, which is equal to a plus b into bracket a minus b. Here a as 1 and b as sine theta. What we will get? Square root of 1 plus sine theta into square root of 1 minus sine theta is equal to square root of 1 square minus sine square theta. Similar like a square minus b square. But since it is under square root, we have kept it as it is. Now let's simplify numerator. Square root of 1 minus sine theta into square root of 1 minus sine theta. It is simple to simplify. It simply becomes square root of 1 minus sine theta square. Let's put back numerator and denominator value. So numerator is square root of 1 minus sine square theta and denominator becomes square root of 1 square minus sine square theta. Simplifying this, what is square root of 1 minus sine theta bracket square? It's simple, 1 minus sine theta. For the moment, we are keeping denominator as it is. To simplify denominator, we will use trigonometric identity sine square theta plus cos square theta is equal to 1. Simplifying it, we get cos square theta is equal to 1 minus sine square theta. Let's put back this value. We get 1 minus sine theta upon square root of cos square theta, which is nothing but 1 minus sine square theta. Simplifying it further, 1 minus sine theta upon what is square root of cos square theta? Simple, cos theta. Simplifying it further, we get 1 upon cos theta minus sine theta upon cos theta. We have already seen what is 1 upon cos theta? It's sec theta. And what is sine theta upon cos theta? It's tan theta. So can you guess the answer? Yes, sec theta minus tan theta. Hence proved. Moving on to the next. Sec theta minus cos theta into cot theta plus tan theta is equal to tan theta into sec theta. Let's solve this. Let's again take left hand side, which is sec theta minus cos theta into cot theta plus tan theta. I want you to focus on two terms. One, cos theta, and next one, cot theta. Why? Because cos theta is nothing but 1 upon sec theta and cot theta is nothing but 1 upon tan theta. Let's use that. So it becomes sec theta minus 1 upon sec theta into bracket 1 upon tan theta plus tan theta. You can again watch our trigonometry basics and trigonometric identities video for better understanding. Let's simplify this. Sec theta into sec theta minus 1, that it means sec square theta minus 1 upon sec theta. We have made the base common. Tan theta into tan theta is tan square theta. So 1 plus tan square theta upon tan theta. Again, we made the base common. Now again, using what we have learned in trigonometric identities, 1 plus tan square theta is equal to sec square theta. If we rearrange this, we get sec square theta minus 1 is equal to tan square theta. We are going to use both. How? Just notice both the numerator. 1 plus tan square theta, we can replace it with sec square theta, and sec square theta minus 1, we can replace it with tan square theta. Let's do that. Let's replace these values in numerator. Sec square theta minus 1 is what we get, tan square theta upon sec theta multiplied by sec square theta upon tan theta. Simplifying this, what we get? We get tan theta into sec theta. Hence proved sec theta minus cos theta into bracket cot theta plus tan theta is equal to tan theta into sec theta. Moving on to next. Cot theta plus tan theta is equal to cosec theta into sec theta. Again take left hand side, cot theta plus tan theta. What is cot theta? It's cos theta upon sin theta. What is tan theta? It's sin theta upon cos theta. Let's simplify this by cross multiplying with denominators on both sides. Cos theta into cos theta plus sin theta into sin theta divided by sin theta into cos theta. What we get is cos square theta plus sin square theta upon sin theta into cos theta. Now tell me which trigonometry identity you will use. You have to focus on numerator. What is numerator? Cos square theta plus sin square theta. Trigonometric identity which we will use is sin square theta plus cos square theta is equal to 1. Hence we get 1 upon sin theta into cos theta. Simplifying it further, 1 upon sin theta into 1 upon cos theta. What is 1 upon sin theta? That's right, cosec theta. What is 1 upon cos theta? That's right, sec theta. Hence, we have proven cot theta plus tan theta is equal to cosec theta into sec theta. Let's move on to the next. 1 upon sec theta minus tan theta is equal to sec theta plus tan theta. What I will do now is I will give you some hints to solve this, and let's see if you can do it on your own. Hint number 1, multiply numerator and denominator by conjugate of denominator, that is sec theta plus tan theta. Hint number 2, use trigonometric identity 1 plus tan square theta is equal to sec square theta, or simplifying it, sec square theta minus tan square theta is equal to 1. Try to solve this on your own, otherwise the answer would be given after this. Were you able to solve the last problem on your own? If yes, that's great. If no, don't worry, keep practicing. That's the mantra. You have to keep practicing at least 2 to 3, 4 times. Let's move on to the next. Sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. To prove this, we will assume sin square theta as A and cos square theta as B. Why? Let me explain this to you. We are again going to use A square minus B square is equal to A plus B into bracket A minus B, but slightly in different way. Let's see how. We have already assumed sin square theta is equal to A and cos square theta is equal to B. If we square on both sides, we will get sin raised to 4 theta is equal to A square and cos raised to 4 theta is equal to B square. Sin raised to 4 theta minus cos raised to 4 theta is equal to sin square theta plus cos square theta into bracket sin square theta minus cos. So our LHS is sin raised to 4 theta minus cos raised to 4 theta. Now let's put up the expanded terms for sin raised to 4 theta minus cos raised to 4 theta. Now tell me, what is sin square theta plus cos square theta? Yes, it's 1. So what we get? 1 into sin square theta minus cos square theta. We have already used sin square theta plus cos square theta is equal to 1. Let's rearrange the terms and reuse them. So rearranging, sin square theta is equal to 1 minus cos square theta. Putting this value of sin square theta into the equation, we get 1 minus 2 cos square theta. Let's see the next problem. Sec theta plus tan theta is equal to cos theta upon 1 minus sin theta. Again, for this problem, I will give you some hints and you try to solve it on your own. Otherwise, at the end of this sum, there would be a solution given. But try it on your own first. To solve this problem, you focus on right hand side first, that is cos theta upon 1 minus sin theta. Hint number 1, divide numerator and denominator by 1 plus sin theta, which is additive inverse of denominator 1 minus sin theta. Second, use A square minus B square concept with expansion A plus B, A minus B. Apply this. And third, use trigonometric identity sin square theta plus cos square theta is equal to 1. Simplifying this, cos square theta is equal to 1 minus sin square theta. Replace this value and try to solve this on your own. Let us solve the next problem. We have to prove if tan theta plus 1 upon tan theta is equal to 2, then we have to show that tan square theta plus 1 upon tan square theta is equal to 2. We have tan theta plus 1 upon tan theta is equal to 2. Let's square on both sides. We will get tan theta plus 1 upon tan theta bracket square is equal to 2 square. Now let us say A is equal to tan theta and B is equal to 1 upon tan theta. If we assume this, then A plus B bracket square is equal to A square plus B square plus 2AB. If we replace this by the values we assume, we will get tan square theta plus 1 upon tan square theta plus 2 into tan theta into 1 upon tan theta. Tan theta gets cancelled out. We get tan square theta plus 1 upon tan square theta plus 2. Replacing this, we get tan square theta plus 1 upon tan square theta plus 2 is equal to 2 square. Simplifying this, tan square theta plus 1 upon tan square theta is equal to 4 minus 2. Hence, we get tan square theta plus 1 upon tan square theta is equal to 2. Moving on to the next, tan A upon 1 plus tan square A bracket square plus cot A upon 1 plus cot square A bracket square is equal to sin A into cos A. To prove this, let's take LHS. Tan A upon 1 plus tan square A bracket square plus cot A upon 1 plus cot square A bracket square. I want you to focus on these two terms. Do you see trigonometric identities in this? Yes. 1 plus tan square A is equal to sec square A and 1 plus cot square A is equal to cosec square A. You can watch our videos on trigonometric identities again for better understanding. Tan A upon sec square A bracket square plus cot A upon cosec square A bracket square. Now tell me, what is 1 upon sec A and 1 upon cosec A? 1 upon sec A is equal to cos A. Now if this is true, then 1 upon sec square A is equal to cos square A. Similarly, 1 upon cosec A is sin A. If we square on both sides 1 upon cosec square A, we will get sin square A. Let's replace this. We will get is tan A into 1 upon sec square A is becomes cos square A. But here there is a 1 upon sec square A bracket square. That's why what we will get is cos square A bracket square. Similarly, cot A into what was 1 upon cosec square A? Sin square A. But cosec square A square is there. That's why we get sin square A square. Now what is tan A? Tan A is sin A upon cos A. And what is cot A? Cot A is cos A upon sin A. Let's replace the values of sin A and cot A in this equation. What we will get is sin A upon cos A into cos raised to 4A. Cos raised to 2A square becomes cos raised to 4A plus cos A upon sin A into sin raised to 4A. Cancelling out one cos A and cancelling out one sin A, we will get sin A into cos raised to 3A plus cos A into sin raised to 3A. Let's take out sin A into cos A common out of this. We get sin A into cos A into bracket sin square A plus cos square A. But we have already learned sin square A plus cos square A is equal to 1. Replacing this, we will get sin A into cos A. Hence, proved. Right. Let's move on to the next problem. Sec raised to 4A into bracket 1 minus sin raised to 4A minus 2 tan square A is equal to 1. To prove this, let's take LHS. Sec raised to 4A into bracket 1 minus sin raised to 4A minus 2 tan A. Focus on these two terms. Sec raised to 4A is equal to 1 upon cos raised to 4A, as sec A is equal to 1 upon cos A. Similarly, tan square A is equal to sin square A upon cos square A, as tan A is equal to sin A upon cos A. Let's put these values into the equation. We get 1 upon cos raised to 4A into 1 minus sin raised to 4A minus 2 sin square A upon cos square A, which is nothing but 1 minus sin raised to 4A upon cos raised to 4A minus 2 sin square A upon cos square A. Now I want you to focus on this term, 1 minus sin raised to 4A. We have already seen so many times a square minus b square is equal to a plus b into bracket a minus b. Let's assume a square is equal to 1 square, that means 1, and b square is equal to sin square A. Let's put these value, what we will get, 1 minus sin raised to 4A is equal to 1 plus sin square A into bracket 1 minus sin square A. Let's replace 1 minus sin raised to 4A with this expanded form. We get 1 plus sin square A into bracket 1 minus sine square a upon cos raised to 4a minus 2 sine square a upon cos square a. Now focus on this term 1 minus sine square a. We have already seen sine square a plus cos square a is equal to 1. So cos square a is equal to 1 minus sine square a. Let's replace this value now. We get 1 plus sine square a into bracket cos square a upon cos raised to 4a minus 2 sine square a upon cos square a. Cancelling out cos square a with cos square a, we get 1 plus sine square a upon cos square a minus 2 sine square a upon cos square a. Now since base is similar, we can simplify this as 1 plus sine square a minus 2 sine square a upon cos square a. Now I want to focus you on this term 1 plus sine square a minus 2 sine square a. We have also learned a minus b bracket square is equal to a square plus b square minus 2ab. Now what we have is here this term is 1 square, that means 1 plus sine square a minus 2 sine a, which is nothing but 1 minus sine square a. We get 1 minus sine square a upon cos square a. But what is 1 minus sine square a? We have already seen over here 1 minus sine square a is cos square a. So we get cos square a upon cos square a, which is nothing but 1. Hence proved. Let us take the next problem. Let's prove tan theta upon sec theta minus 1 is equal to tan theta plus sec theta plus 1 upon tan theta plus sec theta minus 1. To prove this, we will use one trigonometric identity, which is 1 plus tan square theta is equal to sec square theta. By simplifying, we get tan square theta is equal to sec square theta minus 1. Further simplifying, we get tan square theta, which is nothing but tan theta into tan theta, is equal to sec theta plus 1 sec theta minus 1. How did we simplify sec square theta minus 1 as sec theta plus 1 into sec theta minus 1? By using a square minus b square is equal to a plus b, a minus b. Let me explain. Sec square theta minus 1 is nothing but sec square theta minus 1 square. Expanding this, we get sec theta plus 1 sec theta minus 1, like as a plus b, a minus b. We will use this simplified form of trigonometric function 1 plus tan square theta is equal to sec square theta to solve this sum. So let's write it down. Tan theta into tan theta is equal to sec theta plus 1 into bracket sec theta minus 1. By rearranging, we get tan theta upon sec theta minus 1. We have sent sec theta minus 1 onto the left hand side and 1 tan theta to the right hand side. So we get tan theta upon sec theta minus 1 is equal to sec theta plus 1 upon tan theta. Now let's add 1 to LHS and RH. We get tan theta upon sec theta minus 1 plus 1 upon 1. We need to add 1 to both numerator and denominator is equal to sec theta plus 1 upon tan theta plus 1 upon 1. So we have added 1 to both LHS and RHS. If we were to do this addition, we need to make sure that denominators are common both on LHS and RHS. So what we do is cross multiply. We get tan theta plus sec theta minus 1 upon sec theta minus 1 into 1, but I have not written it over here, as sec theta minus 1 into 1 remains sec theta minus 1 is equal to, on right hand side we get sec theta plus 1 into tan theta upon tan theta. I have just simplified it further. We get tan theta plus sec theta minus 1 upon sec theta minus 1 is equal to sec theta plus tan theta plus 1 upon tan theta. Let's rearrange. Let's send tan theta to LHS and tan theta plus sec theta minus 1 to RHS. We get tan theta upon sec theta minus 1 is equal to sec theta plus tan theta plus 1 upon sec theta plus tan theta minus 1, which is nothing but what we were supposed to prove.